examples of fractions and opposite numbers, all right? And so reciprocals are, what do you think they are? Yes?
What do you add the reciprocals together and it'll give you
Well, we're going to take a look at that. We'll see if that works. Okay? Say that again.
Fraction flip-flop.
Really, and this is the best way to explain it, right? So if I have 2/3, the reciprocal of 2/3 is 3/2. All right, so basically your numerator becomes your denominator and your denominator becomes the numerator. Now this, remember how the mathematical definition of a reciprocal is a number times its reciprocal gives you 1, right? Well, look at 2 times 3 is 6, 3 times 2 is 6, 6 over 6 is 1. Okay? A reciprocal, I like your definition. It's basically the numerator becomes the denominator, denominator becomes the numerator, or the definition of a mathematical term is when you multiply a number by its reciprocal, your product is 1. Okay? All right. So, ready for this? Okay, what's the reciprocal of 2? What? What's the reciprocal of 2? Stop. Not quite. Not quite. 1/2, right? You just flip it. So 2 is 2 over 1. So the reciprocal of that would be 1 over 2. Okay, so now what we had talked about earlier, I want you guys to look at number 2. Doug says the opposite of -2/5 is 5 over -2. Is Doug correct? Okay, so Doug says, this is the key term right here, the opposite of -2 over 5 is 5 over -2. Is he correct? Quickly, talk to your groups. Go. Hey. All right, what do you think? Shh. What do you think?
Can I get a drink of water?
Okay, yes. What do you think?
It's the reciprocal of 5 over -2 is the reciprocal of -2 over 5.
Right, good.
It's not correct.
Good, because look, the opposite of -2/5 would be what?
It would be 2/5.
Yes. So opposite is the same distance from 0, but on two sides of the number line, right? One positive, one negative. So these are opposites. If I could spell that right. Okay. All right. -2/5 and 5 over -2 are reciprocals. Do you guys understand the difference between the two? Okay? Because that's super duper duper important. Okay? All right, now, what we're going to get into in this section is finding the product of, and this is not in your book, obviously, right? But I just want to really quick go through this with you guys. All right, so multiplying decimals. Okay, we're just going to do this really, really, really fast. And shoot, I'm sorry, I left my whiteboards in my garage. They're sitting in there. So, okay, if I have a multiplication problem like this, these are two rational numbers, right? Can you have 70 cents? Can you have 70 cents? Yeah, you can have 70 cents. Can you have $4.80? Yeah, you can, right? And so therefore, if I multiply these, a really quick review for you guys. So this is what I tell everybody. I put my blinders on. I ignore the decimal point. Okay, so I take my decimal points out. And this now becomes 7 times 48. I put the number with the most digits on top and the number with less digits on bottom. and I just multiply these, right? So 7 times 8 is?
45.
How about 56? All right, so carry the 5, bring down the 6 in the ones place. 7 times 4 is? Plus 5 more is?
33.
Okay, all right, now I go back and I say, okay, how many numbers are to the right of the decimal? I have 1 there and 1 there. So I have a total of 2. So my decimal point is located right there. I move it over 2 times. So the answer to 7/10 times 4 and 8/10 is 3 and 36/100. Now I can double check that, right? This number is less than 1. Isn't it less than 1? This number is about 5. So if I did this, if I rounded this to the nearest half, this would be half times 5. Half of 5 is about 2.5. So this is fairly close. So I know I probably did that in the correct manner. Okay? All right, multiplying fractions. If I have 5/8 times, and this is where we might get a little bit tricky, but I'm going to hopefully remind you guys. Let's go with, I need a fraction. I need another fraction. Please help me. Yes.
7, 8.
Eighths? Okay, all right. Do you have to have a common denominator when you multiply fractions? Absolutely not. No, 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 no. All right, so here's what I'm going to remind you. When multiplying fractions, please cross simplify first. So take a look at this numerator and this denominator. Is there a number that goes into both of those? Take a look at this denominator and this numerator. Is there a number that goes into both of those? So I can't cross simplify anything. So that means I'm just going to multiply everything straight through. 5 times 7 is 35. 8 times 8 is 64. And since I couldn't cross simplify, there's a good chance that I can't reduce this fraction down. Okay? All right, so once you can't cross simplify, you multiply the numerators, you multiply the denominators, call it a day. All right, so let's do this one. Let's go 5/6 times 8/9. Okay? So if you take a look at this, first thing I'm going to do is I'm going to look to see if I can cross simplify. Is there a number higher than 1 that goes into 5 and 9? Nope, so I can't do anything there. How about 6 and 8? What's the number that goes into 6 and 8? What?
2.
Peace out, people, right? So 6 divided by 2 is 3. 8 divided by 2 is 4. Okay, now I multiply it out. 5 times 4 is 20. 3 times 9 is 27. All right, and I probably can't simplify that. What if you have mixed numbers? 2 and 2/3 times 1 and 1/8. Okay, what do you do in order to multiply these? What do you have to do first? Okay, what do you have to do first?
You turn the whole numbers into the fractions.
Into the fractions.
Add the bottom number to the top.
You're on the right track. So basically, we're going to take this mixed number and we're going to make it an improper fraction. And to do that, you multiply the denominator times the whole number and you add the numerator. So 3 times 2 is 6. 6 plus 2 is 8. So this becomes 8/3. Okay, over here, 8 times 1 is 8 plus 1 is 9/8. Oh, happy day. Because look, okay, is there a number that goes into 8 and 8? What? 8. 8 divided by 8 is 1. 8 divided by 8 is 1. Is there a number that goes into 3 and 9? 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And now I multiply the numerators. 1 times 3 is 3. 1 times 1 is 1. My answer is 3 or 3/1. Okay, so that was a quick, really fast review for you. All right, so let's jump back into the book. Okay, in your math book, turn to page... Ay, caramba. Let's do... Sorry, I just want to make sure. Page 237, please. 237. All right, so here we go. On page 237, we have Mount Whitney Trail starts at an elevation of 8,350 feet above sea level. and ends at an elevation of 14,500 feet above sea level. So here's kind of our little path here. The temperature changes by a negative 5 4/10 degrees Fahrenheit for every 1,000 feet gained in elevation. What is the change in temperature from the starting elevation to the ending elevation of the Mount Whitney Trail? Okay? So, what I want you to do right now is, in your groups, you don't have much time to work on this, I'm sorry. Just start to get the information. So first of all, before we start, let's go through important information. We know it starts at 8,350 feet. It ends at 14,500 feet. And the temperature changes. So it goes down 5.4 degrees, 5 4/10 of a degree, every 1,000 feet. Okay? So, for every 1,000 feet, it goes down. So, that's probably going to be super cold on top. All right, so with your groups right now, can you guys go through and solve this? Go. All right, I know you guys are not even close to being done, but we're going to go ahead and kind of walk through this really quick, okay? So, in order to do this problem, we first have to know what? What do we have to know? What do we have to know? We have to know the change in elevation, right? So how do we find the change in elevation? What do we do? What do we do? Yeah, so we start with the highest, right? And we're going to subtract the lowest from it. Okay? So therefore, if we subtract these, we find that the change in elevation is 6,150 feet. Right? Okay? So, the next thing that we know is this. For every 1,000 feet, it changes by a negative 5 4/10. Right? So, if we have 6,150, right? And maybe we put it, maybe you guys modeled this. I'm not sure. But we have, well, let's start here. So this is 6,150 feet, right? So we're going to go up by thousands. 1,000, 2,000, 3,000, 4,000, 5,000, and 6,000, right? But then we have this little piece left over. So we know it changes by a negative 5 4/10 degrees. So this over and over and over and over, right? But then we come into this little part right there, right? So we could add that up and then find that piece. Agree? Or what could we do? What's another way that you could do this? What? We could. All right, so let's find out how many times it goes into it, right? So we take 6,150, and if you divide it by 1,000, that tells you how many changes it was going to occur. So this comes out to be 6.15, right? Are you with me on this? Okay, and so then all we're going to do is multiply it by a negative 5.4 degrees. Okay, so here we go, our good old multiplication. Woo, this is going to be a good one. Hopefully you guys remember this, 2-digit multiplication. Here we go. 4 times 5 is 20. Carry the 2, bring down the 0. 4 times 1 is 4, plus 2 more is 6. 4 times 6 is 24. No. Put it back. All right, now, placeholder right here. Let's go here. 5 times 5 is 25. Carry the 2, bring down that. 5 times 1 is 5, plus 2 more is 7. And then 5 times 6 is 30. So we're going to add these together. 11, 12, 2, 3, 3, aha. Now, you ready for this? Okay. All right, how many numbers are to the right of the decimal point? Look again. 3. So I'm going to move it over 1, 2, 3 times. All right, and so I get 33.21. However, go back to your multiplication rules. What's a negative times a positive? A what? So here is your answer. So the temperature changed by negative 33 and 21/100ths of a degree from the start of the trail to the end of the trail. Okay, from the start of the trail to the end of the trail. Okay. So make sure you guys have that. Again, 2 different ways of doing it to go through it. And this part right here got a little bit tricky if you did it this way, because you would have had to go through that process of like divide it in order to come up with it. Okay. Comments, questions, or concerns on that? Okay, moving. Were you able to get that written down okay? Yes or no? Okay. All right, so here we go. Turn to page 240. Let's go through a couple of these. A falcon dives for prey. Its elevation changes by an average of negative 11.5 degree, or 11 and 5/10 meters every second. The dive lasts for 3 2/10 of a second. What is the change in the falcon's elevation? What does it mean in context of this problem? Okay, so I want you guys to visually think about it. Here's the falcon, right? All of a sudden, it dives, right? And it dives 11 and 5/10 meters for every second. And how long does it dive for? 3 2/10 of a second. Okay, so what are you going to do to figure out the how far the elevation increased by? What are you going to do? Talk to your groups. Go. All right. All right, I heard it. Okay. All right. So if you think about it, set up a table, because it every one, right? Here's my table right here. So every 1 second, it dives down 11.5. So 2 seconds would be 11.5. 3 seconds would be 11.5, right? You could do, or multiply them. Yep. Okay, so we're going to go ahead over to the side. Yes, unfortunately, not using calculators today. We're going to use our brains. So 2 times 10, that's 1 is 3, and that's placeholder, that guy's done. All right, that's 15. That's 3 plus 1 is 4. 3 times 1 is 3. And how many numbers are to the right of the decimal? 2? Right? So, so it becomes 6.8 meters. But it's diving. So what does that tell you? What?
Negative.
It's a negative. So you can write a negative here, or you can say it's 36 8/10 meters below where it started. Or some vocabulary words that mean it is a negative. All right, this one right here. Remember, when you are multiplying a fraction times a whole number, you have to make that whole number into a fraction as well. So this becomes 1/9 times 27 over 1. Notice, did I put my negative signs in here? We'll talk about the negative signs in a minute. So, is there a number that goes into 9 and 27? What?
3.
Higher. 9. 9 divided by 9 is 1. 9 divided by 27 is 3. Multiply it out. 1 times 3 is 3. 1 times 1 is 1. Now go back. What's a negative times a negative? So therefore my answer is just plain old 3. Okay? Comments, questions, or concerns? All right. Last but certainly not least, a freezer in a lab is set so the temperature changes at a rate of -1 6/10 degrees Celsius every single hour. What is the change in temperature after 4.5 hours, or 4 1/4 of an hour? Ay caramba. So, what do you think we're going to do in order to figure this out?
Make 4 1/4 and the 4 and 25.
Aha! In order to be able to work with these two, they have to be in the same form. So you can either change both of them into fractions, or you can change both of them into decimals. Which one is easier to multiply? Decimals are probably easier to multiply, right? Okay, and that's kind of what we're going to have to do here, because if it's changing every hour to find the total change, we have to make sure that they are, or we're going to multiply it. So, how do you change 4 1/4 into a decimal? How'd you get that? Did you just know that 1/4 was 25/100ths? Nice job. That's good. That's good, good, good. But how else could we change? Yes. What? I love that. 1/4 of 100 is 25. And if you don't know that, you can divide. Right? So 1 divided by 4. So here we go. If we change this into 4.25, and we're going to multiply that by a -1 6/10, right? So we're going to ignore the sign, and we're going to ignore the decimals, and we're just going to multiply these two whole numbers. Okay? So that's 30, that's 12, 13, 14, 15, that's 24 plus 1 is 25, and we're done. So then we move on to this placeholder. That's 5, 2, 4. We add them together forever. All right, and so we get that. Now, how many numbers are to the right of the decimal? 3. Ba-dump, ba-dump, ba-dump. All right, and now go back. What's a positive times a negative? So this becomes -6 and 8/10 degrees Celsius. Okay, do you have any comments, questions, or concerns about that? No, we're okay? So guess what? Here is, I thought we were going to get through this. So you guys will have your quiz on, we probably won't get through that until Thursday. All right, your homework assignment for today is looking at this, 241 to 242. I just want to make sure there was something on here that I wanted to. Yeah, I think we're okay. All right, 1 through 5 all. Okay, so that is your homework assignment.